All right, chemistry students, this is part of problem 6.18, part of the chapter 6 homework. It's actually number 11. So I went ahead and just pasted into this OneNote. I pasted what you're given. So a balanced reaction that I'm going to write larger. A2 plus 2B2, so they're not real chemicals, they're just A's and B's. So we've got a balanced reaction here. And then you're given a figure, and A is the two substances reacting, and B is what is produced. So you're not given any numbers, but you're asked to calculate percent yield. So you're just going to count the molecules that are shown in the figures to come up with what you have, okay? So they tell you A is red and B is blue. So I'm literally counting 1, 2, 3, 4, 5, 6 of the red. So I'm going to say I'm given 6 moles of A2. So I'm writing that underneath A2. And then if I count the blue spheres, I'm not going to circle them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 moles of B2. So 11 moles of that. And they say when these react, the experiment actually produces 1, 2, 3, 4, 5, 6, 7, 8. So B, figure B, is what is produced. So 8 moles produced. And I'm going to put in actual experiment. Okay? So just like any limiting reactant problem, you convert from moles of, in this case, we'll just say reactant A and reactant B, to the moles of product using the balanced reaction. Okay, so the first part, 6 moles of A2. Converting that to product, you're using the coefficients. So the coefficient here would be 1, and then the coefficient here is 2. Okay, so 1 mole of A2 from the coefficient to 2 moles of product that they say is AB2. So that's going to give you 12 moles of AB2. You have to do that for the other reactant, okay? 11 moles of B2. All right, now we have a 2 to 2 moles. So 2 moles of B2 to 2 moles of AB2. Once again, those are just from the coefficient from the balanced reaction. And that's going to give me just 11 moles of B2. AB2. Now, since 11, this value here is a smaller number than the number 12, this value here, I can say that B2, or the blue spheres, are the limiting reactant, okay? So B2 is limiting reactant. Okay, so I don't need this upper value 12 anymore at all. But I've used this 6, I've used this 11, and now the percent yield is actual product, which produced 8 moles, divided by theoretical yield. Well, this 11 down here is the theoretical yield. Okay, so percent yield is our actual divided by theoretical, I'm just going to put theor period, times 100%. Okay, so that is actually 8 moles divided by the 11, that's that value, that's where that number comes from. And 8 came from above, given in the problem. So that's where those numbers are coming from, times 100%. So you would get 72.7 or 73% if you reduced it down to the appropriate 2 sig figs that you're given originally in the problem. Okay? So that is that problem, 73%. That's how you do it without giving any numbers. You just got to count from the figure. Okay? So thank you for listening.